I covered splines briefly in the sketch section, but pretty much just described how to add a spline. This video will go into much larger depth of how to control splines and how to create splines in different ways. The first thing I have here is a sketch with a couple of splines in it. And I'm just going to right click on it and go to Show Curvature Combs. And this is a setting we're going to be using quite a bit to take a look at our curvature as well as how that curvature changes. And by default this comes in as yellow when deselected and light blue when selected. And we're just going to go ahead and change the color of the deselected curvature combs, as well as change one of the options to add a bounding line. So I'm going to go into the options, and first we'll change that color. And this falls under the temporary graphics shaded. I'm going to go ahead and edit this, and you can choose any color you want. I like choosing the purple because it contrasts with both an undefined line as well as generally any background you're going to be working with. And then the other option for the bounding of the curvature combs is in the sketch option, and it's just called Show Curvature Comb Bounding Curve. So now we can see the bounding curve and how it transitions along this line. Basically, the curvature combs show us how sharp the curvature is, as well as how that curvature transitions along whatever entity that we're working with. For now, I'll go ahead and hide away this sketch and show the arc and spline sketch. So I have two sketches here, very similar. One made up of arcs that are all tangent, as you can see by the relations, and the other is made up of a single spline. And I'm going to go ahead and highlight both, right click, and go to Show Curvature Combs. Whenever you do Show Curvature Combs, it's going to bring you into the curvature scale. In this case, I'll make this quite a bit more exaggerated so this is easier to see. And while these shapes will tend to look very similar when you draw them out, when we actually look at the curvature combs, you can see that there's quite a bit of a difference in how these transition. In a tangent arc, you're limited to C1 continuity, which is tangent continuous. So you can see that the bounding curve ends where there's a tangency. Whereas you can see on the spline, the bounding curve continues on, as this is curvature continuous throughout the spline. Now the advantages of this aren't necessarily readily apparent when you first start working with splines and arcs. But to get a really good looking surface that reflects well, we're going to want curvature continuity throughout. And so this tangent continuous surface or tangent continuous arc isn't going to work for what we want to create. So now I'll go ahead and hide out the arc and spline. The next item I have is two sketches that are a trace of a sketch picture. I have a palm bottle, and on the left I have this traced by arcs, and on the right I have it traced by a spline. One of the advantages of using a spline versus an arc is that you can add points as you go when you're creating the spline, and you can generally create this shape a lot faster because this is all one entity. Whereas for each of these arcs, you probably have to go in and define each radius, and then if you want to add another arc, you'd actually have to delete one out and add two new arcs in to make a change. And once again, the other issue is curvature continuity. And here I'll go ahead and just right click and modify the curvature scale and bring it back down to something manageable. And the curvature scale applies to all of your sketches. So if you increase it for one, it'll increase for all of them. Once again, you can see we just have the tangent continuity without the bounding curve connecting. Whereas with the spline, we have a curvature continuous entity. And as I stated before, the curvature continuity is going to allow the surface, when we create it, to look a lot better and not have discontinuities in the reflection off of the surface, which is going to make it look less attractive. So next I'm going to go ahead and go back into my spline sketch. And for the time being, I'm going to turn off the curvature combs. And I'm just going to talk a little bit about how you create a spline, as well as the options that go along with splines. So once you grab the spline tool, you can simply click in for your first spline point, and that's going to represent the end point of the spline. And then wherever you click, you'll get more spline points. And you'll notice the curvature change as you click and as you move your mouse. You'll see the entire spline change as its remaining curvature continuous. So if you click on the spline, you get some options on the left. We can choose to show the curvature. Once again, this is going to bring us into the curvature scale. The next option here is maintain internal continuity, and it's not immediately apparent what this one does if we have a pretty smooth spline. You see just a little bit of a shift in the handles. But if we give this a much sharper transition, you can see that when we turn this on and off, there's a bit of a shift in the curvature. And this maintain internal continuity option will generally produce better curvature, and that's why it's generally selected by default. We have several controls for each of the spline handles, and each one of these are called spline handles. At each of the spline handles, you'll notice there's a diamond, a triangle, and a point at the end. And the diamond here controls the angle of that handle. And you can see the further I move this in, the quicker this changes based on my mouse movement. If I want more control, I can move this out and modify the angle from out here. This arrow is referred to as the asymmetrical tangent magnitude, and what that just means is it controls the length of the handle on this side. You can also take symmetrical control of this handle by holding down Alt, and now you can see that both sides of the handle are dragged out. And lastly on this, the point at the end controls both the magnitude as well as the angle. At the bottom we have options to reset a single handle or multiple handles. And generally handle 1 or spline point number 1 is going to be the first point you added in, and then this should be 2, 3, 4, and 5. So if I want to reset just handle 2, I can select that, and this is going to bring this back to where I first added it in. I also have the option to reset all handles, and you can also relax the spline a bit, and this will remove some of the sharpness out of the curvature. Lastly, there's the reset all handles, and so if I change multiple handles and things get a little bit hard to manage, I might just want to come back in, just say reset all handles, and this will bring me back to that last position. And on the bottom there's an option called proportional. This is going to remove the spline handle control and allow you to drag the spline around. So if you want to connect it to a certain point, that proportional option will be the way to do it. There's also an option called tangent driving, and the movement that we were doing within the handles are the tangent driving options. You'll notice at this end that this handle is gray and several of the other handles are gray. That means that the tangent driving option is turned off. You can pretty much ignore this though, as once you drag the handle, it'll automatically check that option for you. Aside from the options on the left in the spline manager, if you right click on the spline, you get several other options. Once again, the show curvature combs, and once you show the curvature combs, you can come in and modify the curvature scale. If we want to know the minimum radius, we can turn the minimum radius option on. There's also an option to show inflection points. So if I didn't have my curvature on and wanted to know where the spline was inflecting, that'll easily indicate where those points are. So if I wanted to have a spline with no inflection points, I can drag this out and modify it until these are gone. I can also do that through the curvature combs just by looking at where this bounding curve crosses over. There's also options to add tangency control as well as curvature control. Tangency control is the same as inserting a spline point effectively. So if I choose that insert spline point option, I can click in and add another point of control. And the add curvature control simply removes out the option to drag the magnitude arrows and controls it from this curvature arrow. But you can get the same result just by holding down Alt when you drag those magnitude arrows. Those were the options for modifying a spline. The next thing I'll look at is a 3D spline. So I'll go ahead and show this sketch. And for quite a few of your 3D splines, you'll just be working in between faces or in between geometry that already exists. In this case, I just drew out a 3D sketch of reference geometries so that I'd have something to work with to add in my spline. And the 3D spline works in the same manner as the 2D spline, except that it can be connected to points in 3D space and dragged out in 3D space. This can also make it a little bit difficult to handle, as sometimes the spline can do things that you don't necessarily want it to do in certain planes or in certain directions. So one way to manage a 3D spline is to use this for view. And so you can see as I drag out this point in my trimetric view that I can see what's happening to this spline in different planes. I also have the option of using a sketch triad, and this will allow me to pull that point just in one direction. So sometimes with the 3D spline it's a little bit difficult to tell where you're actually moving your point to. This triad can allow you to just do it in one direction without changing anything in the other directions. Later lessons will go into detail of actually applying a 3D spline into a model, but this is generally how you would go about modifying one of these. The next option I'll look at is called the face tangent, as well as face curvature with a spline. So I have two surfaces that I have pre-made, and I'm just going to go ahead and draw in a 3D sketch. And I'll just make this 2 points. So typically if I just select a spline, I might want to select the face, and I'm control selecting the two. And that'll make this tangent to this face, but it won't leave me any options to control the tangency through the spline handle. So I'm going to go ahead and delete out this tangent. And if instead I select the spline, I select this edge, and then control select the face as well, that's going to bring up options for both tangent to face as well as curvature. So you can see now I can drag the magnitude based on the new tangent face option. And once again, you can also make this equal curvature. And when working with these two surfaces, you might add a spline on the end to control the outside boundary. And if you control select the outside edge as well as a spline and add equal curvature, SolidWorks will say this is overdefined because it's trying to work with both the face as well as this edge. So it can't figure out the correct geometry for this. So there's two different solutions for this. We just want to go ahead and convert over these two edges. And now if you select out the edge, and the splines, or the spline and the edges, you can add that equal curvature option. Alternatively, you can also use the fit spline. And I won't go into too much detail on the fit spline as I'll be covering it in its own lesson. But in this case, we can add a fit spline, and that'll just continue the spline through those two curves. And being able to create splines in this manner is pretty powerful for changing what your surface is going to look like. For example, if I choose a boundary surface, I do have options for curvature to face, but you can see it represents a little bit of a different geometry to being just curvature continuous to these outside edges. So with the curves I created, I can add in a little bit more control. And in the case of the fit spline, I can simply just drag the ends of the spline and then choose this last spline and produce my surface. With the last few operations that I was talking about, I was discussing curvature continuity, which in this case would represent C2 continuity. But for a 2-point spline, I can also create a raised degree spline with C3 continuity. And I can do this in a sketch where I have two curves. And then I add another spline. And then choose the equal curvature. You'll see now there's an option for raised degree or just standard. I'll go ahead and show the curvature combs. And you can see with the raised degree option, we have a smoother transition between these arcs. And that raised degree option just applies to a 2-point spline. Lastly, there are quite a few cases where you might want to create a spline directly on a surface. So here I have a revolved surface, and within the spline pull down, we have this spline on surface option. And here, as long as I'm clicking on the surface, it'll continue to add this to that surface. And you'll notice this tool produces the spline a little bit slower, or it takes a little bit longer to regenerate, as it's trying to calculate the entire time how to keep the spline on this surface. So those are the options that you'll be working with when you work with splines. In subsequent videos, I'll be covering how to use these splines to actually produce the desired geometry that you'll be working with.